enjoy very much when you pick problems, but this time I have no choice. I have to go through some problems that I already picked so we can move on fast. So sorry. My apologies again. I would have enjoyed you picking some problems. Okay. So let's take a look at trig equations. This is the last section of chapter 9. I think it's 9.5. Yes, it is. Okay, what is a trig equation? It's an equation that has trigonometric functions in it. So here is one example. I'd like to start with, I want even a simpler problem than this. So, for example, let's say sine x equals 1/2. Question, what is the period of sine x, or sine? Period of sine is? Okay, so period is 2 pi for sine, and we'll take that into account. So we are asked to find all angles whose sine is 1/2. Sine is positive in the first and the second quadrants, so therefore I will find 2 angles. One angle, which I know has to be 30 degrees, or pi over 6, at the same height with the same 1/2. There is another angle that has its terminal side in the second quadrant. So solving the equation sine x equals 1/2 gives us at least 2 different angles. One angle will be pi over 6 plus 2 pi k, where k, why 2 pi? Because the period of sine is 2 pi. K is any integer, meaning 0, plus or minus 1, plus or minus 2, and so on and so forth. The other option would be, since this is pi, and we know the reference angle must be the same, pi over 6, pi, take away pi over 6, or go back pi over 6, would be 5 pi over 6, plus 2 pi k. These are all possible solutions. What does this k really represent? I can go around the circle as many times as I want. I will find infinitely many angles that end here, and infinitely many angles that end here. How come? Okay, so if k is 0, I get this. If k is 0 here, I get this angle. But if k is 1 in the first one, I get this plus a complete rotation. If k is 2, I get this plus 2 complete rotations. And I can go on forever in both directions. That's what that k represents. All possible solutions. Going around the circle as many times as you want. So k can be 0, plus or minus 1, plus or minus 2, and so on and so forth. So this you can say, it has 2 distinct solutions, but actually infinitely many that end here, and infinitely many that end here. Second trig equation, this time this was just a simple example. I selected a few from here that I thought were interesting. For example, 24 on 750. Please stop me for questions on what I'm presenting. That's very important. Yes?
Will we have like negative k? So if it's negative,
Yes,
it goes
yes,
around,
yes, yes.
So it goes around the circle
Yes.
this way?
Yes. Yes.
Yes.
Yes, yes, yes. It can be any integer. Yes. Okay, so tangent x minus 2 sine x tangent x equals 0. In the previous example, we had a function that was sine, and sine is defined where? Defined. Everywhere. Everywhere, right? When we talk about the inverse function, yes, we say it's between negative pi over 2 and pi over 2, but otherwise I can plug in sine anything I want, right? It has no restrictions, normally, right? Good, so now I have a function here that is tangent. A tangent is not defined everywhere. Tangent is not defined where its denominator is 0. What is the denominator of tangent?
Sine.
Try again. Cosine. So cosine cannot be 0. Why am I going to write that? Because this is a restriction for x, like we did with rational equations. So This, first I have to write that cosine x cannot be 0. Whatever solutions I get, I have to make sure that when I plug those solutions in cosine, the answer is not 0. Because if the answer is 0, tangent is undefined. Now, the rest should not be very difficult. Obviously, what am I going to do?
Take out 10.
Very good. So 1 minus 2 sine x. So we have two possible options, either tangent x to be 0 or sine x to be 1/2. I'm going to refer back to this, so I'm not going to write the solutions for sine equals 1/2 because we already discussed them. They're the same. But I'd like to discuss tangent equals 0. Now, you will say, okay, but tangent equals 0 means sine equals 0. Yes, that's fine. So always try to simplify everything. So obviously from here, sine has to be 0. On the unit circle, I know exactly where sine is 0 because sine is measured on the y-axis. So I know at these points, sine is 0. What points? 0 and pi. So I will write x equals 0, not needed really, plus 2 pi k, or x equals pi plus 2 pi k. So, of course, I have to write what k represents, 0, plus or minus 1, plus or minus 2, and so on and so forth. And I can move on to a next problem before I check whether cosine of all these solutions, we had pi over 6, of course it's not 0. We had 5 pi over 6, of course it's not 0. But now I have to check if at 0 cosine is 0. No, cosine is 1. What about pi? No, it's not 0 because at pi is -1. So I will say all these 4 solutions, actually infinitely many, are acceptable. Yes? Yes. I checked. Cosine is not 0 for any of those. Okay. So let's look at a possibility or a type of an equation. I couldn't find one here, but I need to show you one like that. So let's say cosine 2x equals 1/2. Any questions on the previous problem? Yes, please.
How did we,
So I said, don't ask questions about the test and stuff like that. That's what I meant. But for this, we have to communicate. I cannot just.
So how did we find that those values were equal to cosine?
I thought in cosine, I thought 0. 0 at 0 is 1. At pi is -1. I plug those angles in cosine.
Oh, okay.
So cosine 0 is 1. Cosine pi is -1.
Okay.
Cosine pi over 6 is the square root of 3 over 2. Cosine pi over 6 is negative the square root of 3 over 2. So none of these 4, they are infinitely many, but 4 distinct make cosine 0. Good. Okay, this is a slightly different situation. Because now, again, we look at the unit circle, cosine of an angle equals 1/2. Remember, it's just right here in the middle. Cosine is positive in the first and the fourth. So we will have an angle that ends in the first quadrant and an angle that ends in the fourth quadrant. Both angles have cosine 1/2. Can anyone give us the reference angle of these two angles with cosine 1/2? Excellent. So then 2x equals pi over 3 plus 2 pi k because cosine has period 2 pi. Sorry. I need to come back here for a second. The period, although no, it's okay. I used a sine. If I had used tangent, I did not solve for that. I solved for this, so which is okay. But if I solve for tangent, I would have to write pi k. Why? Because we know the period of tangent is pi, not 2 pi. But this is okay because I changed it into sine. Perfect.
why did you change it to sine?
Because tangent is sine of a cosine, and a fraction is 0 only when the top is 0.
So you're just solving it for the sine part.
So tangent is sine x over cosine x. A fraction is 0 when the top is 0. And you will get the same answer. Okay? Is it okay? Other questions? Okay, so let's go back here. Now this time the angle is not x, so I have to act accordingly. So it's 2x, which is pi over 3 plus 2 pi k for an angle here in the first quadrant. Of course, k is 0, plus or minus 1, plus or minus 2, and so on and so forth. And what is the other option? So we have from 2 pi, we subtract pi over 3. From 2 pi, I subtract pi over 3 to get this angle. So how much is 2 pi minus pi over 3?
Three.
5 pi over 3, of course. 5 pi over 3 plus 2 pi k. Notice that we solved for 2x, or twice x, not for x. Now we're ready to solve for x. So when we divide both sides by 2, this will give us x equals pi over 6 plus pi k. And this one will give us x equals 5 pi over 6 plus pi k. Of course, with k, any integer, like 0, plus or minus 1, plus or minus 2, etc. Okay, one more, and then we can continue with something else. I let you choose. Would you like to see, which I think this is important, one of these two? Either or both. Maybe we should do both. Both, okay. I agree. So, sine of theta minus pi over 2. They say equals the square root of 2 over 2. This is the trig equation. Sine of an angle is positive. Back to the unit circle. Sine is positive in the first and the second. We have to, can anyone give us the reference angle? Excellent. Indeed, pi over 4. So then theta minus pi over 2 can be two different things. The first one, of course, is pi over 4. Sine, we're talking about sine, so plus 2 pi k. And the second one is 1, 2, 3, right? 3 pi over 4 plus 2 pi k. Notice that we had to solve for theta minus pi over 2. This was the angle in sine. What do you think we have to do next to finalize the answer? Add pi over 2 to both sides. So pi over 2 plus pi over 4 will be 3 pi over 4 plus 2 pi k, right? Pi over 2 plus pi over 4. We have to multiply this by 2. 2 plus 1 is 3. And this one will be pi over 2 plus 3 pi over 4. Again, we multiply this by 2 and I get 5. So 5 pi over 4 plus 2 pi k. Of course, I have to mention 0, plus or minus 1, etc. And this is the complete solution set of that trig equation.
Are we always gonna have to state k?
Okay, yes. Sorry. Okay, last one that I wanted to talk about here, and of course we will have to review. When we review, we'll have to do more. Sine twice t equals cosine t. This is a totally different situation. Why is this a totally different situation? It's because I see two trig functions in this trig equation. I have to get rid of one of them somehow. One thought. Second thought is, I know what sine twice the angle equals to. Once I use the identity, that should smoothen all the things here with this equation. So how do I, what is the formula or the identity for sine twice t? Excellent. 2 sine x cosine x. So this piece is 2 sine t cosine t minus cosine t equals 0. And now from here on, it goes back to what we already covered. I'm going to have to factor out cosine t and then get two solutions. in sine and cosine, and then more solutions for t, right? So cosine t, 2 sine t minus 1. I get again 2 sine t equals 1/2, so I'm not going to copy that solution. So we have it already. So earlier. And the other one is cosine t equals 0. And here we have two options for t. Plus 2 pi k plus 2 pi k, because the period of cosine is 2 pi. So where is cosine 0? Cosine is measured on the x-axis, so it will be 0 at and 3 pi over 2. That's what we have to put in, and we're done. I don't have to check anything. The trigonometric equation did not have a ratio that was undefined anywhere. It did not have a tangent, secant, cosecant, or cotangent. So all solutions should work. Of course, we have infinitely many, but we have two solutions coming from this, distinct ones, and two coming from this. Yes, of course, we can get to more complicated situations in which we have to factor, or we get solutions that are not something we know. So for example, this is not factorable. So I would probably get sine x equals 0.3. I don't know what angle is that. So yeah, they can get more sophisticated. But once you understand the mechanism, this should be okay. So we can go back later and look at other problems. So this is trig equations. The next topic we have to look at are the conic sections. And I like this graph that they present in the book, because I'm sure you're going to ask why we even need to look at conic sections, like the parabola, hyperbola, and the ellipse. So why we need to do that? It's not very clear, but this is a dome at, I think it's the National Statuary Hall in Washington, D.C. So it's difficult to see because I think the copy is not very good. But the dome is in the form of the ellipse. So if mathematicians wouldn't come up with that, probably the builders wouldn't know how to build that dome. And what is so special about it is because everywhere you are, if you whisper, it's heard all over the place because of the way it is built. So what are the conic sections? So this is one application. We're not going to be able to get to applications. But, so what are they? So ellipse, hyperbola, and the parabola. And you can say, we talked about parabola before. True. But we haven't talked about this one, which is not a function. As an example. Okay? So let's start with the ellipse. So this is chapter 12. Conic sections. 3. Ellipse, hyperbola, and parabola. So an application that you will see in physics mainly, for example, for the parabola, one example is the satellite dish. That is a parabola. Here's another application. So that's what I was just talking about, the parabolic reflector or the satellite dish. That's what it is. It has a focus. It is a parabola. And we have some more specifications to look at, more things to look at. Also, the human eye uses a lot of analytic geometry. So the optician, all their instruments and what they use to look in your eyes, they have a lot of connection to what we're doing right now. Okay, so let's start with the ellipse. Another conic section that we discussed a long time ago is the circle. And we do remember, I hope, the x minus h, everything squared, plus y minus k, everything squared, equals the radius squared. The circle should be here, together with the other three. Well, it's not. We discussed this a long time ago. And we also had that handout, right? And we dissected it quite a lot. Well, what is the center of the circle? H, comma, K. We're going to use this H and K for all the other ones to find maybe what is called the center, but not all of them use the word center or center of the ellipse, hyperbola and parabola. So for the parabola, I cannot say center. Okay, and I have to say vertex. So that's why I didn't want to use a terminology that does not apply to all of them. So please keep this in mind, and we're going to start the ellipse. The equation of the ellipse, and first of all, what is an ellipse and how is it determined? Very interesting. Here is the graph. So how did they come up with the ellipse? They fixed 2 points. They, with a thread, oh, I do have my thread. Okay, so assuming that I have here fixed 2 points at any distance you want apart, and I go around, of course I can't go over my hand, so I go around and I create the ellipse. That's how I draw the ellipse on the other side as well. So this point, the sum of the distances between the two foci and any point on the ellipse, the sum is the same for any point on the ellipse. So this distance plus this distance will be the sum the same when you add them for any point on the ellipse. And that's what they're showing here. These are they're called foci, and going around with a thread around the foci, the distance for any point on the ellipse for this point. This plus this is the same with, if the point were here, this plus this will be the same. Okay? As you see, I had the same distance, right? I use the same all around for any point on the circle. So the sum of the two. Okay, the ellipse has what is called a major axis and a minor axis. It can be, the major axis can be on the horizontal or it can be on the vertical. Very possible. So obviously we have two situations to look at. Any questions? Okay. So here is x squared over a squared plus y squared over b squared equals 1. This is the equation of the ellipse. With center at 0, 0. Looking at the equation of the circle, can you come up with the equation of the ellipse that will not have the center at 0, 0? I know you can. Just dictate and I'll write it. Very good, of course. Thank you. Exactly.
So a squared and b squared both equal 1. Then you have
No.
a circle.
No, I did not graph. I did not graph, sorry. I will, just this moment. So let's look at an example before you ask your question. Very good question, sorry about that. So let's take a look at, let's say, x squared over 4 plus y squared equals 1. What does this mean? It means that a squared equals 4, 2 to the left, 2 to the right. This point and this point will be the vertices on the major axis. I don't see anything here. Oh, obviously it's 1. So then b squared equals 1, which means 1 above, 1 below. Here's the ellipse. The minor axis two. Major axis 4. Now please ask your question. So A and B, they don't have to be 1. So that has nothing to do. This point here is negative a comma 0. This point here is a comma 0. This point here is b 0 comma b, and this one is 0 comma negative b. So let's write all of those. So negative a comma 0. a comma 0, 0 comma b, 0 comma negative b, this point. So now the question is, where are the foci? I don't know, but we can determine them. So I'm just going to plot them, but we'll determine where they are exactly. So this is F1, and this is F2, and the coordinates for F1 will be negative c, and you can say what is c in a moment, and F2, c comma 0. C squared equals a squared minus b squared. This is how we get the coordinates of the foci. Okay, so I have a squared, which is 4. I have b, which is 1. 4 minus 1 is 3. So the coordinates of F1 will be negative the square root of 3 comma 0 and the square root of 3 comma 0. So then F1, negative the square root of 3 comma 0, and F2, the square root of 3 comma 0. Why? One more time. Because c squared equals a squared, which is 4, minus b squared, which is 1. So c squared being 3, c is plus or minus the square root of 3, and that's how I get these. So again, what are those foci? The points from which all points on the circumference of the ellipse are found at the same sum of distances. And the center, of course, is 0, 0. How does a ellipse with a major axis on the y-axis look like? Still looks the same. Notice that I don't normally change those, but your book does, so I don't want to confuse you. I found some errors in the book when I was looking at it to select the problems ahead of time. I can show you where they are. So we assume that this is larger than B. So A larger than B. Let's look at a few examples on how to graph, how to identify, and I would like to start by identifying. So let's take a look. So we're given some graphs. Are these ellipses? Yes, they are. So the question is asking us to determine the equation of the ellipse. Just choose one. Choose any that we can easily identify, A and B, right? A and A, B and B. 52. Which one? 52. 52, this one. Okay, so obviously it looks like the major axis is on the y-axis. So under y squared, we would have a bigger number, right? So I see that this is negative 6 and that's positive 6. I see that this is 2 and this is negative 2. I see that the ellipse is centered at the origin. So I'll say for 52, we have a equals 6, which means a squared equals 36. We find that b equals 4, which means b squared equals 16. Since it has the major axis on the y-axis, we will have to write x squared over 16 plus y squared over 36 equals 1. And we identify the equation of the ellipse.
So,
Yes, please.
So when A is bigger under Y,
Then the ellipse is, the major axis is on the y-axis.
the major is Y and minor is
The minor, yes, the minor is going to be 8.
It's stretched out.
No, it's stretched this way. So the major
the major
is
is just whichever
is 8.
smaller.
Yes, no, yes, the major is whatever. So the major is 12 and the minor is 8.
But what if the major and minor are the same?
It's possible. Then it's a circle.
Yeah, yeah.
Then you don't claim major and minor are the same, or?
Right, if they are the same, it's a circle. We don't even mention it as an ellipse. If they are the same. Yes, Simon?
It was the same question.
Okay. Good. So let's take a look. I would like to, for example, here it says identify the endpoints of the major and minor axes as well as the foci. So I see two major types of problems. One that is a kind of a straightforward one, which is a shifted conic. It does not have is centered at the origin. And the other type is when, and we had these examples with a circle. We are thrown at an equation, and they're asking us, do your magic and see what it is. So this is what I think we should look at. So let's start because these are already in that form. So you know that this is x squared over 100, obviously, what? 10, 10, right? And 8, 8, right? So it's on the x-axis, the major axis, 10, 10, 8, 8. But let's work on this one for a moment and see what that looks like. Something like this, it doesn't matter. I selected that, but it doesn't matter. And again, one of these. So let's start with 13 though, and then 16, of course. So in 13 we're asked, this is 13 on 995, we're asked x squared plus 9y squared equals 1. They say write the equation of an ellipse in standard form and identify the endpoints of and major and minor axes as well as the foci. Okay. As long as I have 1 on the right-hand side, you see there is nothing under x squared, but nothing we mean 1, and plus, this has to be changed into 1 over 9. So the standard equation of an ellipse centered at the origin has to have 1x, 1y, and 1 on the other side. It has to have plus. If it doesn't have plus, it's not an ellipse. And I had to flip this into 1 over 9 in order to be able to determine the a and the b. Obviously, this is bigger than this. This must be a squared, this must be b squared, and the major axis is on the x-axis. Do you agree with that?
Yes.
Okay, so then a squared equals 1, and b squared is 1 over 9, which means a is 1 and b is 1/3. They're asking us not to graph it, we can, but they're asking us only to identify the endpoints of the major and minor. So since it's centered at the origin, this will go from -1, 0 to 1, 0, as we know. And here it will go from the minor, from negative, so 0, negative 1/3. It will go up to 0, 1/3. So these are the endpoints, or the vertices.
So that's the answer.
That's it. So -1, 0, 1, 0, and 0, negative 1/3, 0, 1/3. That's all that is to it. Say it again? Oh, yeah.
In this case, again, negative for a would be on the minor or on the major axis.
Yes, because that's -1 to 1, and negative 1/3 to 1/3. Yes.
Whichever one has the most stretch, that's the major.
Yes. That's why it's major, the longest. Yeah. Okay. So other questions for me? Okay, moving on to 16. Yes, please.
Why did you say like 1 over 9? Where did that come from?
Because this is the standard equation, and I have to have 1, and I have to have 1. If I don't have 1 in front of x squared or parentheses with x, and 1 in front of y or parentheses with y, I cannot identify correctly a and b. I can identify correctly a and b only if these numbers are 1. That's the standard form, yes.
So can we have other than 1? Like any other number other than 1?
In front?
Yes.
Never. You will not be able to identify a and b. If you don't have 1 here, you will not be able to correctly identify the denominator.
Okay, so we have to bring it down.
You always have to flip it,
Okay.
not bring it down. You have to flip it, because when you divide y squared by 1 over 9, you get 9y squared. It has to be the same. So whatever change you make, you have to be able to reverse it and get the original one.
Right.
You cannot just say, okay, I'm going to bring 9 to the denominator. No. When you divide this by this, you get 9y squared. Is that what you meant?
Yes, and we will always have that positive sign in between.
If it's not positive, it's not an ellipse.
Okay.
Excellent. Yes. Very good. Okay, so moving on to 16. Same page. Any questions? Go ahead.
Is that the 1 or 2?
6.
Two? Okay.
What did I do?
You're just asking how to spell ellipse.
Yes.
Okay, next problem. We have x minus 2 everything squared over 81 plus y plus 1 squared divided by 16 equals 1. They want the same thing, but this time I would like us to graph it. So first of all, is it an ellipse? Maybe it's a circle. Is it an ellipse? Yes, the circle doesn't have denominators. So although it has plus between two terms, but it cannot have a denominator. Okay.
What if the denominators were the same?
It is a circle, and you will multiply by it, and you'll get the radius. Better?
Because you get back there now.
Right. Good question. Okay, can anyone give us the center of this ellipse?
2 and minus 2.
Careful, careful. One more time.
Minus 2, 2 and minus 1.
2, -1 is the center of the ellipse. Very good. Awesome. Can anyone give us a squared and b squared?
A squared is 81.
Excellent.
And
Then b squared is 16. Can anyone give us a and b then?
A is 9.
And 4? So obviously, is it on the x-axis or on the y-axis? So where is the major axis? Good. Careful with the center, right? 2, -1 is the center. A is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 9. 4, 1, 2, 3, 4. 1, 2, 3, 4. And here's the ellipse. Can anyone give us the coordinates of the vertices? Remember, the center is 2, -1, and this must be 4, and this must be 8. I'm sorry, 9, of course. How did I come up with 8? Okay, so can anyone give us this vertex? So I'm going to call them A, B, and C, and D. So coordinates of A, please. B, C, and D.
7.
So for A is -7, comma. Good. And then the other one, or let's go around the ellipse. So B, what will you say about B? 2, 3. Very good. What will you say about C?
11.
So you will say 11, yes, indeed. And -1, correct. And the last one, D, you will say 2, -5. Very good. Okay. Last one here, and we can move on to hyperbolas. So let's see how we handle this. Totally different story. Much more work than with a circle. Same idea, though. But you have to be very careful with this one. Okay, 9. So I selected 26, so we can choose another. That's page 995. So 9x squared plus 72x plus 16y squared plus 16y plus 4 equals 0. And the question is this an ellipse? The answer is I have no clue. Potentially, I don't know. If I make this look like this, if I perform the magic and I come up with this, I will say yes, of course, it's an ellipse. But if I can't come up with this, then I'll say sorry, it's not an ellipse, it may be something else. Okay, so what do you think we have to do? complete the squares, but you have to be very careful. This is not a straightforward situation. So these are the terms with x squared, and these are the terms with y squared and y. Okay. We cannot complete the square if the leading coefficient is not 1, which means I have to factor out 9 before I start. So in here, 9, x squared plus 8x, leave some space. We'll come back to it in a minute. Plus, I cannot complete, yes, very good. So we factor out 16, leave some space, plus 4 equals 0. So y squared plus y. Now I need to complete the square. The middle coefficient is 8, divided by 2. I get 4. Square 4. What do I need to add? 16. But I cannot simply add 16 without subtracting 16. I am allowed to add 0. By adding 16 and subtracting 16, I'm adding 0. No deal. No change. Okay, so now let's see, the middle coefficient for y is 1. I divide that by 2. I square 1/2. What do I get? 1/4. So I'm going to add 1/4 and subtract 1/4. No deal. I am giving you a quarter and I'm taking half. Now I have to complete the square. What is it? Yes. Please use brackets now. X plus 4 squared minus 16 plus 16. And tell me what you have in parentheses. What is this? Very good. And minus 1/4. At this point, I have to distribute. But be careful how we distribute. We distribute 9 to the first term and then 9 to negative 16. We distribute 16 to the first term and then 16 to negative 4 to eliminate brackets. Ready for that? So 9, x plus 4 squared minus 9 times 16. How much?
144.
Are you sure? Good. Thank you. Y plus 1/2 and 16 times negative 1/4 minus 4 plus 4 equals 0. Do we all understand this step? Forget about the numbers and the calculations. Do we understand this step? Yes? Okay, perfect. So these two go away. Now I have 9 x plus 4 squared plus 16 y plus 1/2 squared, of course, equals 144. I am getting close. Compare these two and tell me what I need to do next. For sure. Divide by 144. So I have 9 x plus 4 squared over 144 plus 16 y plus 1/2 squared over 144 equals 1. I will say for certain now that this is an ellipse. It has 1 on the other side, not 0 or a negative number. It has positive between two squares with x and respectively with y. But I have to bring this to the denominator. And I have to bring this to the denominator or simplify. And I can't simplify. So when I divide 9 and 144 by 9, what do I get? I get in the denominator 16. When I divide 16 by 16 and 144 by 16, I get 9. And now I am absolutely certain. And I know how this looks like. And it is an ellipse. I need the center. I need a squared. I need b squared. Let's also determine the two foci. Negative 4, negative 1/2. Very good. How much is a squared?
16.
How much is b squared?
9.
So then how much is a? And how much is b? Is this, does this have a major axis that is horizontal or vertical?
Horizontal.
Horizontal. Any questions?
Can you show how you completed the square again?
From the beginning? Why don't we use another problem? Okay, let's choose another.
We didn't do the focal.
I know, we can do the foci later. Or on the next one, the hyperbola, same thing. So you just have to plot them, you need to determine C, right? You have to determine C squared. Okay, you want to do that. Let's do that and then choose another. Let's do that. Okay, so it's better to visualize. That's why I wanted to graph. So the center is at -4, -1/2 right here. Then we will determine, so A is 4, so it was -1/2, yeah. So right here. And 1, 2, 3, 4, so right here. B is 3, so this was 1/2, right? So 1, 2, 3, 1, 2, 3. Okay, so here's the ellipse. So obviously the foci are somewhere on the same axis, or they have to have the same y value as negative as the center. That's why I asked you whether it's it has an axis that is horizontal or vertical. If the axis is horizontal, then the y coordinate of the foci, right? The y coordinate of both has to be the same with the center, the y coordinate of the center. So now we have to determine the C. In order to find the C, remember it's C squared equals A squared minus B squared. So A squared minus B squared is 7. So C squared equals 7, so C equals plus or minus the square root of 7. So one of them will be negative the square root of 7, and the other one the square root of 7, comma, -1/2. Is that clear? Once you establish where the major axis is, you plot the center, then you will be able to determine the height of the foci, which is the y coordinate, and then you will determine the x coordinate with the formula. Are you okay? Perfect. Yes.
How do we know like which one is negative and which one is positive? Under root 7.
So, what do you?
Like F1 and F2, which one do we write negative under root 7?
Oh, I see what you mean. Hold on. A squared minus B squared. Very good question. Hold on. So they have to be, once we determine, very good, thank you. So this is not correct. This is correct. So this is the negative square root of 7 minus 1/2. So that's the C, right? And then this one has to be opposite. So we have to, one way would be to determine this distance and then make sure that we have the same distance on the other side of the center. Is that clear what I'm saying? So between -4 and negative the square root of 7, and then I have to measure it and put it on the other side. We're not asked to determine that, so this is just something that I wanted to add in. But a very good question, thank you. So once we determine this, then the other one has to be on the same distance on the other side of the center. Thank you.
We just add that to -4.
You subtract from -4. Or if you want, if you're subtracting a negative number, then you're adding it. Yes. Yes. Very good. Okay, so let's choose another one with completing the square. Or we can move on to the hyperbola, and we're going to have the same type of problem with the hyperbola. Or we choose one right now. Which one? Which one?